Ever since ancient times, there has been the belief that matter is composed of tiny particles. It wasn't until around the 1800s that the modern theory of the atom emerged and presented the idea that atoms combine in distinct ratios. But ratios means logic, and logic means it can be turned into a video game. And that's about all the motivation I needed to make this happen. Here's how it went. So to start this project, the first thing we'll need are some atoms. And atoms have electrons as well, so let's add some of those in. I'm pretty sure electrons move around a bunch. Let's make it happen. Okay, that's a little excessive, and on second thought, this isn't that helpful. I'll revisit it later. I think it's a good idea to get the basic mechanics of the tower defense down before expanding on the chemistry too much, so let's take care of that. The atoms are going to act as towers, so first we need them to be able to shoot things, and the target should also have health and be able to be destroyed. Now let's add a destination for the targets that needs to be defended. Then we just need a spawner for the enemy targets, and we have a basic gameplay loop. The idea from here is that each atom will have different stats or properties, and the atoms should be able to combine into molecules or compounds to create upgraded towers. It's been a while since I've done much with chemistry, and I naively thought I'd be able to come up with some dynamic code that could handle atom combination automatically. For simple compounds that follow something called the octet rule, this task is fairly easy. Atoms have different shells of electrons, and for fulfilling the octet rule, I just need to define the number of electrons in the outer shell for each atom, and see if one atom plus another equals 8, because in most cases this will form a stable compound. The group numbers on a periodic table are convenient for this, because the columns are generally ordered by how many electrons are in the outer shell. So it's just easy arithmetic to find some valid combinations like magnesium oxide or sodium chloride.
Actually, dude, it's solved.
However, once we move into compounds with more than 2 atoms, things get a bit more complicated. In addition to the outer shell of the atom, factors like electronegativity, ionization energy, atomic size, and more can all affect chemical combination. While some compounds can be created through generalized rules, at least in my experimenting, it seemed like too many edge cases were needed to create a dynamic script-based composition system. I ended up going with a more hard-coded approach where I provided a list of valid compounds that could be created with the atoms that I included in the game. But I did try something a bit more dynamic with visually forming bonds, which I'll explain later on. The hard-coded list is implemented as follows. There is both a shop and an inventory in the game, and when you buy atoms from the shop, you can either place them directly on the field or click on existing atoms to compare them to the atoms in your inventory and see if any combination can be formed. This was a little tricky to set up, but basically a button is created for every possible compound with the available atoms, and you can click the button to upgrade the atom into that molecule or compound. I started with just a couple atoms, then added the rest to the game, and made it so that the atoms that are lower in the periodic table have a higher rarity. Higher rarity means that they will have better stats, but they will cost more and be less likely to appear in the shop. The main stats for the atoms are damage, attack speed, and attack range. I added a visual indicator to show the attack radius, and I also added a new damage type that's a laser instead of a projectile. The main thing that's lacking at this point is visualizing the compounds. There's a type of diagram called a Lewis dot structure that is convenient for showing the octet rule I mentioned earlier. Perhaps with the compounds predefined, it will be easier to create a dynamic script for showing these Lewis structures. The basic rule I decided on is this. If an atom can give an electron to either reach 0 electrons or give another atom a total of 8 electrons, and both atoms have at least 1 electron available, then both atoms will give up an electron to create a bond between them. In a compound with more than 2 atoms, each atom will compare itself to every other atom in the list and follow that rule. And there are also edge cases like hydrogen gas, where both atoms should give up their electron to form a single bond. You can see the new bonding structure in place with hydrogen sulfide in this clip. I didn't have time to create rules and conditions for multiple bonds, and some cases are still not covered in the simple rules that I used, but it at least gives a somewhat interesting visual basis to work with. I then added a few more mechanics, such as a stat sheet to show the stats on current elements and compounds, and I gave atoms that have available combinations a highlight to show that they are ready to combine. For the enemies, I added a new pathing system, as well as enemy types with different speeds and health values. To make use of this, I drew up a map, and from here I added the final polish onto the game. Here's how it looks. There are now a couple different turret types, such as trap turrets that place damaging traps on the track, as well as buff turrets that increase the damage of projectiles that pass through their field. There's also a limit to how many atoms or compounds can be on the field at one time, so you have to strategically make use of the best compounds available. There's a lot more I wanted to do with this project, such as adding acid damage to acid compounds, or explosive effects to compounds like methane, or have a water compound unlock new effects for surrounding turrets. But I've run out of time for this project, for the moment at least. If enough people seem interested in it, then I may revisit this to expand on the mechanics more, and give it a more interesting game loop. As it stands, after a few waves, the game enters infinite mode with increasing numbers of the most difficult enemy. I really haven't had time to balance and playtest properly, so I'm not sure what the most powerful compounds and effective tactics are. If you'd like to try out the game for free, I've placed a link in the description. I'm curious to see how far people can make it into the infinite mode with the options available. Thank you all for watching the video and supporting the channel. Until next time.